as you can guess, if you're putting traffic on the internet going somewhere far away, there's almost an infinite number of paths that your traffic can take through all these different routers all over the internet. And that's one of the nice things, one of the interesting things about the internet is it's so reliable because we have all these different paths that we can go on. If somebody, if a router somewhere isn't working properly, there's other routes that our data can take. But you can use the traceroute command to see how your traffic is getting from your server to, say, another server somewhere else in the world. You can see, exactly where your traffic might be having trouble, or where there might be a spot where your traffic's getting lost. There's two commands in Linux. It's traceroute, all one word, and I'm just going to do drexel.edu. And that'll start tracing. So this server that I'm doing this from is actually, I think it's in Los Angeles, so it's got quite a ways to go to get to Philadelphia to get the drexel.edu. So it's going to kind of take this circuitous route sort of around the country, and you see there's lots of nodes that it's going through. I'll run the same command in Windows, but in Windows it's tracert. So it's a little shorter in Windows. In your book they just show the tracert command, but in Linux and Unix it's usually traceroute. So do tracert. Drexel.edu. Now I'm right outside Camden, New Jersey. So you can see here it went from my router. It went straight to Camden, New Jersey for Verizon because I'm at home right now. Then it goes to another router in Camden, then somewhere in New York it looks like, and then from New York it kind of loops back around to Philadelphia, and finally lands at drexel.edu. So we should see drexel.edu pop up here. There we go. So it finally ended up at 66.8, 66.83 rather, which we know is drexel.edu. So much faster, only 12 hops to get there from my home here in South Jersey. But over here from Los Angeles, it kept going and going and going. In fact, it never actually found it. It gave up after 30 hops. But certainly if I increased that hop count, it probably would have eventually found it. Another command our book does not talk about that I'm going to give you is path ping. So path ping is interesting because it will it'll ping each one of the nodes. So it's sort of like a trace route combined with a ping. And when it's done, and you can see this is going to be done just here in a second, so it's going to calculate the statistics. 300 seconds is a few minutes. So I'll pause this while it's calculating. So you can see it completed, and it's showing us some statistics. So basically, what it does, it tries to do a ping to each one of the nodes in the path to see, and really a lot of systems now. I'll talk about this in another one of the other troubleshooting videos, but a lot of systems don't answer to ICMP echo. So the ping command basically, a lot of systems don't respond to that. So this isn't always useful, but for internal things, where things are responding to ICMP echo, then it could be useful. So that was the path ping command, which you won't find in your book, but I wanted to show it to you.